In this work, we present TrackDLO, a method for tracking the shape of deformable linear objects under occlusion. Deformable linear object shape tracking takes RGB-D stream as input, then extracts a set of nodes and edges to represent the shape of the object. One of the approaches for solving this problem is non-rigid registration. Our proposed method, TrackDLO, accurately tracks the shape of deformable linear objects in real time under occlusion without information from modeling, simulation, visual markers, or contact. This is achieved through preserving the total length of the deformable linear object, as well as imputing the displacement of occluded nodes from that of the visible nodes using Motion Coherence Theory. TrackDLO tracks self-occluding deformable linear objects without modeling entanglement. This is achieved by replacing the Euclidean distance with the geodesic distance in the kernel, describing how pairs of nodes influence each other's motion, as well as in the registration associating DLO nodes to the points in the 3D point cloud. TrackDLO introduces a kernel that only penalizes lower-order spatial velocity derivatives, which leads to improved accuracy for tracking under occlusion. We performed quantitative evaluations for different kernels, and then selected the one with the lowest error overall. We also released our code and data publicly on GitHub. The TrackDLO algorithm takes two things as inputs, the point cloud at the current time step t and the DLO nodes at the previous time step t-1. First, TrackDLO estimates the visibility of DLO nodes and registers the visible nodes to the current point cloud. Then, it remaps the visible node positions to preserve the distance between adjacent nodes. Finally, it registers all DLO nodes to the new point cloud. The visible nodes will have the remapped node positions as references, while the occluded nodes will have their displacements imputed from the displacements of the visible nodes. Geodesic proximity is encoded in the imputation step. Here is an example of TrackDLO in action. In this experiment, we test the preservation of object topology for knot tying. TrackDLO successfully tracks the object's complex topology shape, while the other algorithms fail to resolve self-crossing.
In conclusion, TrackDLO is a real-time vision-only algorithm for DLO tracking. It is robust under tip, midsection, and large-scale self-occlusion. TrackDLO achieves the lowest tracking error compared to 3 other methods of DLO tracking. We thank the Illinois Space Grant Consortium, NASA, and the Sofin Memorial Fund for supporting this work. Please find the TrackDLO code and data on GitHub using this QR code.